Iridescent objects can be captivating, with their lustrous colors that shift as the object moves. You can see iridescence in butterfly wings and in soap bubbles. Scientists are interested in replicating the iridescence that occurs in nature to make brightly hued displays and color-shifting paints without pigments. When color arises from the structure of the materials rather than their chemical makeup, scientists call the effect structural color. Researchers at Penn State and MIT developed a way of harnessing structural color inspired by a type of iridescence they saw in oil droplets they were studying. A similar effect appeared on the lid of a petri dish they filled with warm water. Maybe you've seen this effect too. When warm water sits in the dish, water vapor condenses into droplets on the lid and produces iridescent swirls. Researchers wanted to understand what causes those colorful displays. At first, the researchers thought the colors might be a simple rainbow effect, caused when spherical water droplets refract and scatter sunlight into a range of colors. But that didn't quite add up with what they were seeing. Something else was going on, and it was related to how light interacts with the structure of the particular droplets the scientists were studying. Remember, they saw iridescence in water droplets on a petri dish lid and in oil droplets. Their oil droplets are made of two oils of different densities that join together at a curved interface. That curved interface provides the right conditions for a phenomenon called total internal reflection. If the angle of the light rays entering the droplet is just right, the light doesn't go straight through the droplet. Instead, it bounces off the concave interface where the two oils meet. All that bouncing means some light rays will travel farther than others to reach your eyes. That difference allows different wavelengths within the rays to interfere with each other, leading to colors that change based on viewing angle. Now back to the petri dish. The warm water droplets that condense on the underside of the petri dish lid also create total internal reflection at the concave interface where the water droplet meets the air. The color patterns we see depend on the size and curvature of the droplets. The researchers studied this effect further by making different sizes of oil droplets using a microfluidic device. They could tune the curvature of that oil-to-oil interface by adding surfactants to the water bath, and thus they could control the colors. They can even create patterns with a light-responsive surfactant and a stencil. The researchers modeled the iridescence produced by their various types of droplets in 3 dimensions, seen here on a plastic dome, to better understand how the different variables controlled the colorful displays. Shin-Hyun Kim, who studies structural colors at the Korea Advanced Institute of Science and Technology, says this model potentially provides a simple method for adding structural color to various systems, without requiring delicate engineering of surfaces at the nanometer scale.